O-Calc 6 represents a major improvement in the O-Calc line in that it allows you to perform operations not just on single individual poles, but on entire lines of poles. It vastly improves your efficiency when working with groups of poles that are logically or physically connected together. If I go to the New Line Design tab, we'll open up an existing line of poles, and we'll pick this one right here. And what you'll first see is that on a land base, and we have many choices for land bases, I see my individual poles, and if I zoom in I can see my cross arms and the pole itself and the insulators and the spans as they go off. And as you are used to with O-Calc, I can perform various edit operations here. I can right click on anything and get all of the operations that I can perform on any of these structures as if they were in the inventory or the 3D view here in the overhead line design view as well. Let's go ahead, and I'm going to open up the line design auxiliary panel, and here I see a list of all the poles and in their order as connected. I can, if I wish, visualize them in profile. So for example, I can look at the poles as they're lined out. In this particular case, elevations have not been assigned to these poles, but we can assign elevation to these poles as well. I can export side, top, and 3D views out to DXF and other CAD formats for use. I can export poles out to shape files for including into other GIS sources. And I can perform certain sorts of edit operations. So first of all, let's look at the 3D view. And one of the things I can do is I can change the scale so that the horizontal scale allows me to more easily visualize the line of poles. If I have them out at 100%, sometimes it's hard for me to pick down the line. And any pole that I select becomes the active pole. It becomes the pole that I'm editing in my inventory. And I can walk down the line and I can see various things about various poles, like so. I can reposition poles, and well, it's the first important thing to understand here is that under the covers, these are individual O-Calc poles the way you're used to, but they understand their relationship to each other, and the spans understand that they go from one endpoint to another endpoint. And so if I do something simple, just to demonstrate this, like select a pole, and I'll just rotate it. As I rotate it, look what happens to the spans. You notice they stay hooked on to the correct insulator. They rotate, even though under the covers, this is a pole with 3 spans on it, this is a pole with these 3 spans on it. If I were to separate these PPLX files and deliver them individually, they would keep these geometries. But in fact, while they're connected together in the line design mode, they maintain the proper relative geometry so that the endpoints stay the same. And that's true even if I do something like grab this cross arm and lower it down. You notice that the end drop rise heights on the spans on either end totally understand that I'm performing that operation, and they adjust accordingly. I can then go ahead and recalculate any given structure, and this one's in fact overloaded, as you might expect by the way it's got some asymmetric loads that aren't backed up by a guy. But in addition to doing that, I can go into the line design mode, and I can say, rather than solving that individual pole, what I'd really want to do is solve the entire line. And now what I'm going to do is sweep the wind around the entire line, including the fact that there are in fact spans that are providing some nominal guying force from one structure to another, and that will be included. So I'll go ahead and calculate. You see it's relatively quick. It spins around, and it tells me that in fact the very worst pole for the whole bunch is pole number 1 with an MCU of 198% when the wind was at 30 degrees. So let's go back to our line design and see if that makes any sense. Here is in fact pole number 1. It's a dead end, but doesn't have a guy on it, so it makes perfect sense to me that in fact it's overloaded. It's overloaded to the tune that we just saw. And so I go back to my 3D view, and like you would always do, I'm going to say that I want to perform a guying operation. There, I've backed up that pole. Now he passes to the tune of only 37%. If I go back to my line design and you see now the guy that I just added is shown there visually on the screen. If I go ahead and resolve this entire line, again sweeping the wind, what we'll find is that we can look and see that the next structure is now pole number 5. So it allows me to quickly go through whole lines, fixing all the problems until the whole line just passes, and I don't have to go from pole to pole. I don't have to worry about what my edits are doing to those poles. That means, now let's take a look at the sort of edit operations once we have a line of poles loaded up that you can do that actually in regular O-Calc would be fairly time consuming. Let's take a simple case. If you look at these poles, they're very straightforward. It's just a cross arm with 3 wires on. There's no underbuild. Let's say that I'm doing a proposed addition of telco cables to this set of poles. I select this set of poles. So I'm going to say 1, 2, 3, 4, 5 because I have to tell it what to do at any given juncture. And I'm going to say I want you to do a stringing operation all the way down this set of poles. So I go to my master catalog and I pick a single bolt with telephone wire on it. I tell the system that that's my stringing assembly, and that's new obviously in O-Calc 6. And now I go back to my line design and I say perform stringing for all checked poles. We'll start out just saying we want to put it at, 23 feet. And say go, and under the covers what it has done is walk right down that line of poles and put at the 22-foot AGL mark the communication cable that I specified all the way down the line, and it's put it on this pole going this way and this pole going this way, and then indicated that they're locked together as shown by this small link symbol. And now again I can perform all my various edit operations. If I go back to my line design view and I go to the pole manager portion and I want to say I want to change a pole's position, I can type in the latitude and longitude where I want that new pole to be, or I can just click on the map. Let's say I really want it to be here. I say OK, and you see the pole moved over. All the spans properly elongated, all the spans got shorter, and everything automatically was taken care of. I can also do something like, if I go to my 3D view here and I say for this pole, I happen to know that I want to, have a little more room under here because there's a proposed driveway going to go in or something like that. And as with regular O-Calc, all the things you can do in O-Calc, I can also do in O-Calc Line Design. So I can, for example, go into Google Street View and I can look and we can go and we can see well, these poles aren't very well positioned for this land base, but you can actually see that, in fact, everything is placed, everything is rendered in 3D on the map in the correct location, and so I can know what I want to do. So let's go here and I say that I need to substitute this pole, and I'm going to substitute that pole for let's call it a 55-footer, and I'm going to tell it that I want everything to stay tip relative. Go ahead. The pole jumped up. I'm going to do the same for him. Take him, and I'm going to perform a substitution. Again, make him a 55-footer. Everything's tip relative. He jumps up. And you see it's making my life very easy because all of the nearby poles are having their geometries adjusted as well, so that I know, what needs to be done. And there we go. So that edit operation was pretty straightforward. And yet I can still turn around and take these individual PPLX files and deliver them to customers if need be, or use them for other operations. So that's sort of the idea of line design. We won't do any more edits right now. Oh, actually, we'll do one more. So if I go in here and I say that I want to edit this span, and I'm going to do something that doesn't make a heck of a lot of sense. I'm going to say that I want to change its type, but I'm only doing that because it's something that's visually apparent. I go for this entire circuit, so it understands connectivity. I'm going to change it, and you would never do this, but I'm going to change it to a secondary only because I know that causes it to change color. And you see it change color, but not only that, you notice the connected spans on, in fact, the connected poles also changed color. So if I go look at my 3D view, you can see all the connected spans all the way down the line got adjusted, and they all got turned into secondaries. And I can undo that, and I will, because that doesn't actually make any sense what I did there. Another thing that you can do in O-Calc 6, and you can do this in both line design mode and regular mode, is you can reposition items. So if I take this insulator and I put him down on the pole like this, and I say I want to move him, not only do I want to move him, but I want to move him and I want him to set him to be a pin. Oops, I'm at a post, so let me undo that. Move him there. Move and set type as a post. He becomes a post insulator. He goes in the correct location. And so just as easy as that, I can change a horizontal construction to a vertical construction. I can take that insulator, I can blow him away. And again, that's an operation that in earlier versions of O-Calc would be somewhat time consuming. You'd have to copy them and change type and so on and so forth. So in addition to the fact that the span on the proximal poles on either side also got adjusted, and this span's geometry also got adjusted so that the span's angle and length are all correct to go to the far support. It just makes my life a lot easier when I'm dealing with series of poles that are in fact connected. In later videos, we'll see how this helps us out when we're doing clearance analysis as well, because there's actual connectivity. Tagging a single span or a single set of spans means that that span now knows its type and its clearance rules all the way down the line, and I can get a very quick set of clearance rules out of the system. Let's, without doing any more edits, just sort of look at what else we can do in the system. I have the ability to put shape files behind my data. So if I have existing shapes files or GeoJSON files, and let's see what I have here. And I'm going to go ahead and turn off. So it just so happened the shape file was the roads for the same area it was. But now what we're looking at is shape files. But let's say that instead of shape files, what I actually had was cadastral files that showed property lines. One of the things I could do is, again, go into my catalog and pick an assembly or a series of assemblies to act as my stringing assembly. But I can now use them. So we'll select this as our pole, and I'll go to my add drops tool, and what this does is put it in add drops mode, and I'll put 22 foot high. And now let's say that I had property lines here. If I just said bang, 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 just as easily as that, I've added drops to that pole. Now we'll go to this pole, and again we'll go to tools, add drops. Okay, bang, 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 bang. Go back to my 3D view, and again, now we see let me pop that back up. So here's my pole, here's my drops, go into my properties. I have the ability to sort of declutter this view, so I can show only the items that go pole to pole, only the items that go from poles to structures that aren't members of the current line design, or I can see the selected pole only. or I can see all the spans. So it's pretty flexible, and it helps me do the operations that I'm trying to do. In addition to that, I can do something like, rather than, we'll go back to our GIS files, we'll turn off the GIS files, we'll go back to our map view. There's a built-in land base that we provide that does the whole continental United States and territories. But if you have map sources you'd rather use, let's take, for example, I want to use OpenStreetMap, what I can instead do is hook to the OpenStreetMap servers, and I can use that as my GIS backdrop. So now I'm basically going out to a map server, either cloud-based or in my own intranet infrastructure. And so if I have a particular set of GIS apps or GIS data sources, or I want to use cloud-based data sources, or I want to use satellite photogrammetry or satellite imagery, or I want to use keyhole data or something like that, I can put whatever I want as my backdrop, and the system supports that and then draws the line that I'm currently editing on top of it. For performance reasons, I'm going to go back to my vector-based map. So we saw editing poles, we saw putting GIS behind it, we saw adding underbuild stringing. Let's talk a little bit about violations, for a second. One of the things that's very exciting in O-Calc 6 with line design is that clearance analysis is now performed in 3D. So if, for example, I go to my obstructions list and I add a tree, and I'm going to put it at a known latitude and longitude, and it has a known width and a known height, it goes ahead and puts the tree, oops, didn't mean to do that, and delete, yes, click when done. If I go to that pole in my 3D view, you'll see that now in fact there is that tree there. And if I've tagged things, so let me go ahead and tag this cross arm. So I'm going to say that for purposes of analysis, this belongs to clearance group 1, so it's a clearance group 1 item type, and we'll look at the rules in a second. What that's saying is not only is that cross arm, but everything hooked to that cross arm and everything connected to everything hooked to that cross arm all ended up being part of group 1. So now if I go to my violations tab and say what violations do I have, it's going to tell me, oh look, there's a span to tree violation on the span that goes from pole 1 to pole 2. So that's a pretty big improvement from the clearances and violations you could perform in earlier versions of O-Calc. And if, for example, I set up clearance rules that say that there need to be certain span-to-span distances, what I can just do is keep editing until this list is cleared out, and then I know all my violations are gone. So it basically gives you dynamic violations, and it gives you the dynamic ability to edit it and reevaluate it until, for example, a proposed new joint use attacher is done, and then just as easily as that, you've indicated what the make ready work needing to be done on all the poles all the way down the line is, and you can just spit out your make ready report and you're done. Other tools, I can do things like, let's say I want to do, and actually here's a pretty long span right here. I select this pole, which is pole number 4. So I want to go from pole 4 to pole 5. So I select pole 4 and pole 5. And then I say edit, and then I say split spans and insert a pole. And just as easily as that, it will automatically split all the spans, add the correct cross arms as copied from either pole A or pole B if they're the same, or pole A if they're not the same, and put them on there. And now if I have a new proposed location for that, for example, I can go to him and I can say I want to adjust his position, and really I'm going to move him over here. And in pretty short time, I've performed a remediation action where I've added a new pole, and let's go back to the 3D view, and I've inserted all the spans, and I might want to fix him up by rotating him around a little bit so he's a little like that, or I can automatically do it. Similarly, I can go in and I could just as easily go to my line design and I can pick him, and I can say what I'd really rather do is remove this pole and bridge the spans all the way across back to the original. So if I go edit, remove pole and merge spans, boom, it takes the pole out, it puts all the spans back. If I do the difference report, it'll tell me the length of all those spans, and in pretty short order I can do again the proposed change, and I didn't have to go edit the surrounding PPLX files, remembering what the new span lengths were and making sure to correct them and set the new angles and so on and so forth. I think that's a pretty good overview of everything we've got. There's a lot more sort of helper tools. So for example, I can do things like taking a current dead end, and I can say that I want to extend that, and I want to go to here, and it understands that what I want to do is, move that down, and then I want to fix the span rolls, so I can say that I can go to my 3D view, and I can go to him. Whose span roll do I want to fix here? Actually, I want to go to him, and I want to put that here. I want to take him and put him here, and then, oops, didn't want to put him on the pole, I wanted to put him on the cross arm, and now I fix my span rolls up, and now I have my new construction, and I can do my bill of materials for what would be involved in adding this new pole and running things like that. And if I wanted to put the underbuild under there, I could, and so on. So there's tools to do that sort of thing. There's so I can extend lines, I can trim lines, I can branch lines, I can add branching circuits, I can automatically add branching circuits. I can create whole new lines. So for example, if I close this line and I say something like, I go and I open an existing stub pole in from my inventory. It doesn't have to be a stub pole, I'm just going to happen to use that. And actually this is going to be an interesting one because it'll show off another new functionality of O-Calc 6, because this is a pole that uses dead end insulators. If I go into my line design and I say I want to, let's just pick a new location, I want to there we go, this is a good location. I'm going to put in a new line of poles, so I say File, use the new line wizard, pick the latitude and longitudes, and I can take these latitude and longitudes out of a CSV file if I wish, across the street, like that, and now I'm done. I say it like that. What do I want to call it? I'll just overwrite an existing one. And just as quickly as that, the system went and made all those PPLX files, hooked them all together, and you'll notice, because it understood that that pole was using dead end insulators, that it was supposed to use the new jumper feature of O-Calc 6, and rather than taking two spans and putting them on a single insulator, it put a matching dead end insulator on the other side of the double arm and put a jumper to keep connectivity. And so just like we saw earlier, the connectivity is maintained, the edit will go right down the line. And so if I click this and I say edit him, and I'm going to do the same really cheesy edit that I did before and say make him secondary just so he turns red, not only did he turn red, but the jumper turned red and everybody turned red down the line. And if I look at my overhead view, they're all red. It understood what to do. So that's, in a nutshell, what line design does. There's a lot more to it than that, obviously, but just as an introduction, I think that gets us started. And then in later videos, we're going to do a lot of information about how these edits are performed, how the system works under the covers, what else you can do, how to write plugins that actually can work with line designs instead of just single poles, and so on and so forth.